Welcome to David Alexander Maths Tuition. This is chapter 14b on y equals e to the power of x. So what we need to remember is, well, not a lot really, we just need to remember that e is just a random number in the same way that pi is 3.141. E is just another irrational number, but e is a number, so it's 2.7182. So we know from when we're sketching graphs before that 2 to the x, if I'm just doing a really rubbish sketch of 2 to the x, that's 2 to the x, it goes through 0, 1. 14 to the power of x, again, just a sketch on its own, just an exponential curve going up, asymptote being the x-axis, and it's again going through at the point 0, 1. So e to the x is exactly the same. Here is my sketch of e to the x. It's just an exponential curve that is going through at 0, 1. So when you're just doing the sketch, it could look exactly the same as 2 to the x, 3 to the x, 5 to the x, a million to the x. It's an exponential curve going through 0, 1. I mean, if you're drawing it with side by side with 2 to the x and 3 to the x, then it's a little bit steeper than 2 to the x, but not as steep as 3 to the x. Why? Well, because it's 2.7 to the power of x. Okay, there we go. This is e to the x. Fairly unspectacular, looks like a lot of the other curves you've seen. The key feature being it goes through the coordinate 0, 1. Okay, so here we've been asked to sketch e to the x, e to the 2x, e to the 3x, e to the 4x, just so that you can understand what they, I mean, you'd never be asked to sketch all of these on top of each other, but it's handy to know roughly what they look like. So e to the x we know is our usual exponential curve that goes through 0, 1, and the line y equals 0 is the asymptote. Now e to the 2x is going to be similar but just much steeper. So there we go. So this is y equals e to the 2x. So it goes through 0, 1, whereas it's above e to the x when we're getting positive x values. When we're getting negative x values, it's going to dip underneath, but again, it's never going to cut through the x-axis. It's still, the x-axis is still an asymptote. So e to the 3x would be even steeper still, so this is not going to be much fun. So it will be, again, going through there and going through like so, and again, the x-axis is the asymptote. So let's have a look on Desmos here. So this, notice how they're all going through 0, 1. This is e to the x, this is e to the 2x, this blue line, that would be e to the 3x, and the other one, that is e to the power of 4x. So they're getting progressively steeper, but they're all going through 0, 1, and notice how the x-axis remains the asymptote for all of them. Okay, so sketch the graph of e to the x, 2e to the x, and 3e to the x. So here is e to the x. Key thing being the x-axis is the asymptote and it's going through 0, 1. Now for 2 times e to the x, this is just a stretch vertically with scale factor 2. So I'm just stretching it by 2 in this direction. So all the y values will be doubled. So instead of it going through 0, 1, it's going to go through 0, 2. And it's also going to be a bit steeper. Again, the x-axis will remain the asymptote. So this is e to the x. This is 2e to the x, and 2e to the x will go through 0, 2, and 3e to the x will go through 0, 3, because we're just tripling the y value. So 3e to the x, again, this is fairly poorly drawn, but hopefully you get the idea here. So this one going through 0, 1, that is e to the x. This is 2e to the x, so again, going through 2 and going through 3, that is the 3e to the x. Okay, so here I just want to illustrate the difference between e to the x, 2e to the x, 3e to the x, and just show you what's going on here. So y equals e to the x is our usual exponential that cuts through at 0, 1. The x-axis is the asymptote. Now, here all we're doing, this is just a stretch with scale factor 2 parallel to the y-axis. So this whole graph is just being stretched vertically. All the y values, in other words, are being doubled. So instead of getting 0, 1, we're going to get 0, 2. So y equals 2e to the x will look like this. Again, the x-axis remains the asymptote. So this will be the point 0, 2. And y equals 3e to the x, that'll be the y equals e to the x, but with a stretch with scale factor 3 parallel to the y-axis. So the y values will be tripled, so that is going to go through at 0, 3. And again, the x-axis will remain the asymptote. Notice that all of these lines, they don't cut underneath each other. That's because we have to triple all the y values. So let's just take a look at Desmos where it's a little bit neater. So here is y equals e to the x. So standard exponential, the x-axis is the asymptote going through 0, 1, 2e to the x, a bit steeper because all the y values are being doubled, but it's going through 0, 2, and y equals 3e to the x is going through at 0, 3. So all we're doing is we're just stretching vertically and multiplying all the y values by the number in front of the e to the x. I mean, crucially, if you're just sketching one on its own, you just need to make sure you're getting the y-intercept correct. So here, 0, 1, 2e to the x, 0, 2, 3e to the x, 0, 3. Okay, so some fiddly e functions here. So we're hopefully pretty good at doing e to the x. So e to the x looks like so, going through 0, 1, and it's cutting through, and the x-axis is an asymptote. Now, if I were to draw e to the 0.5x, it's probably easier if I also draw it on top of y equals e to the x. There's e to the x. E to the half x will be not quite as steep. So remember that e to the 2x was steeper than e to the x, e to the 3x was even more steep, so therefore e to the half x is less steep. So here we have e to the x, e to the 0.5x, so e to the 0.4x would be even less steep. Again, it would still go through this point 0, 1, e to the 0.3x less steep, 0.2x even less steep, until we get e to the 0x. Well, 0 times x is 0, and anything to the power of 0 is 1. So y equals e to the 0x would just be a straight line. So if we're going from e to the 1x to the half x to the 0x, then to the negative x means we are going to be sort of going up in the opposite direction. So y equals e to the minus x will look like so. And it's important to remember that e to the minus x and e to the x, they are reflections in the y-axis. Let's use Desmos to look at this a bit more clearly. So this straight line, that is e to the 0x, no problem at all. Okay, so the steeper of these two, that is e to the x. E to the half x is, it's not going up quite as extremely, not quite as steeply. And we can see here that this line here, which is a reflection in the y-axis of e to the x, this is e to the negative x. Okay, so we now need to just make sure we can tell the difference between e to the x and minus e to the x. So we're getting pretty good at doing e to the x, hopefully. So it's a steep curve that goes through 0, 1. Now minus e to the x, the transformation is outside the function, so it's going to affect the y coordinates. So we're just flipping the signs of any y coordinates. So 0, 1 becomes 0, minus 1. So if we're just changing the sign of y coordinates, then that means this is a reflection in the x-axis. The x-axis will still be in asymptote, but the curve will look like this, going through 0, minus 1. Okay, so let's just take a look on Desmos here. This is e to the x, and this is negative e to the x, and as we can see, it's a reflection in the x-axis, and again, the x-axis remains the asymptote for both of those curves. Sketch the graph of y equals 6 plus 2e to the x. Okay, so first of all, I would do e to the x. So e to the x, just a little curve, an exponential curve. The x-axis is the asymptote, and it's going through 0, 1. So what is 2e to the x? Well, it's going to be fairly similar, except it's going through 0, 2. Okay, and what is the asymptote? Again, it's still the x-axis. Now, all I need to do is plus 6 to this. Now, this plus 6 means I'm shifting the whole thing up 6 units. So what that means is that the x-axis, which is the line y equals 0, is no longer the asymptote, but so the new asymptote is the line y equals 6. So let me just say that this is where y is 6. So I'll just illustrate here that that is y equals 6. And I know that the y-intercept is 2 above that, so 6, 7, 8. So all I need to do is just show my curve like so, and just illustrate that that is the point 0, 8. Okay, so here is y equals, or e to the x, I'm assuming. It's going through 0, 1. So if we double it, that would take us to 2. And then if we add the 6, 1, 2, 3, 4, 5, 6, that takes us to this point here, which is the point 0, 0, 8. And the x-axis, or the line y equals 0, was the original asymptote, and now the asymptote is not y equals 0 but y equals 6, and we can see that we are not getting, I mean, it looks like the line is actually on it, but if we were to zoom in it wouldn't be touching it. It'd be pretty close, but it will never actually touch it. Okay, sketch the graph of 5e to the negative x. So let's do, this is e to the x going through at 0, 1. Now 5e to the minus 1x, we need to remember, so this is inside the function, so that's going to affect the x value, so that's going to be a reflection in the y-axis. So that is going to be a mirror image of this using the y as the mirror line, so it will go through like so, still go through 0, 1, and then we need to multiply that by 5, so instead of this being 0, 1, that's going to be just 0, 5. Okay, let's take a look here, so we can see it's a curve that's not shooting upwards, it's one that's shooting downwards, and it's going through at 0, 5. And again, the x-axis is the asymptote here. Okay, rearrange the function of x equals e to the 4x plus 3 into the form ae to the power of bx, where a and b are constants to be found. Okay, so let's just think how we do indices. So x cubed multiplied by x squared is x to the power of 3 plus 2, which we know is x to the power of 5. So actually, what's another way we could write x to the power of 3 plus 2? X to the power of 3 plus 2, we could write that as x cubed multiplied by x squared. I mean, we know all this. This is nothing new, is it? So I can do exactly the same thing here. E to the power of 4x plus 3, that is the same as e to the power of 4x multiplied by e cubed. Okay, so all I can do is e cubed is just this constant. Remember, e is just a number, so that is 2.7182 cubed. But rather than just write something really horrible, I'll just keep it in terms of e. So that is going to be e cubed, lots of e to the power of 4x. And now we've got it in the form that is required. So here a is going to be e cubed and b is 4. So it's really important to know that when you've got a power with a plus or minus, you can turn it into, well, in this case, e to the 4x multiplied by e to the power of 3. Okay, now we're just differentiating. Now, one of the weird things about e to the x is it is its own derivative. So e to the x dy by dx is also e to the x. So the function e to the x is the same as its gradient function. Now, when you've got e to the 7x, what we do here is it's going to be e to the power of 7x multiplied by the derivative of 7x, which is times by 7. So that becomes 7e to the 7x. Probably an easier way is just thinking, okay, I just need to write that number in front of the function. So e to the 3x becomes 3e to the 3x, or dy by dx is 3e to the 3x. So e to the 0.5x, then dy by dx is 0.5 e to the 0.5x. Minus e to the minus 1/3 x, dy by dx is going to be minus 1/3 e to the minus 1/3 x. 5e to the 3x, okay, so 3 is going to come down to the front, so dy by dx is 3 times by 5e to the 3x, and that is 15e to the 3x. Now for this one, I'd expand the brackets, so that is going to be e to the power of x plus x, so e to the 2x plus 3e to the x, so e to the power of 2x differentiates to 2e to the 2x, and 3e to the x, well, that is just 3e to the x. Find the gradient of the curve with equation y equals e to the power of 5x where x is 5. Well, if y equals e to the 5x, then dy by dx is 5e to the 5x. The question is talking about the gradients, so that's a clue we need to differentiate. So this is our function, but this is our function for the gradient. So what is the value of the gradient when x is 5? Well, it's going to be 5 times e to the power of 5 times 5. So it's going to be 5e to the 25. So that is the gradient of the curve where x is 5.